Morning, dear students. Yesterday, or in previous class, we learned about properties of triangles. In that chapter, we learned some rules, and the rules we are called some rules name, that is sine rule and cosine rule, and we did some problems on that rule. In this class, we learn some more problems on properties of triangles. So let us see the first of all, this class objectives are this PPT's objectives. On completion of this period, you would be able to know the projection rule, tangent rule, and problems applying the above rules. So yesterday we learned sine rule and cosine rule. Today we learn tangent rule and projection rule also. So recap. Sine rule. In any triangle ABC, A by sin A equals to B by sin B equals to C by sin C equals to 2R. Cosine rule. In any triangle ABC, A square equals to B square plus C square minus 2BC into cos A, and B square equals to A square plus C square minus 2AC into cos B. Similarly, C square equals to A square plus B square minus 2AB into cos C. Now the new rule, the name is called projection rule. In any triangle ABC, A equals to, here A means side small a equals to B into cos C plus C into cos B, and small b equals to A into cos C plus C into cos A, and small c equals to A into cos B plus B into cos A. See here, if you observe the rule, small a equals to B cos C plus C cos B. That means in terms of BC, the small a is projected. Okay, let me see the proofs. In the examination, there is no questions on proofs, but still here giving the information because too easy to understand and remember. We have to know how it is proved or how it is came. So case 1, if triangle ABC is an acute angled triangle, draw AD perpendicular to BC. See the diagram. Vertices A is on the top and BC is the side in the horizontal line, and draw AD line perpendicular to BC. Then cos B, we can say BD by AB from triangle ABD. Then BD equals to AB into cos B, and from triangle ADC cos C we can write DC by AC. DC equals to AC into cos C. Now BC equals to BD plus DC. In place of BD we can write AB into cos B plus, in place of DC we can write AC into cos C. Next, now BC equals to BD plus DC. So BC means small a, that is length of the side, that equals to AB means C, small c, into cos B, plus AC means B into cos C. So therefore A equals to C cos B plus B cos C. And in case 2, if triangle ABC is an obtuse angled triangle, triangle ADC is a right angled triangle, cos C DC by AC. From diagram you can easily observe. Then DC equals to AC into cos C. In the triangle ABC, angle ABC means angle B. Angle ABD equals to 180 minus of B. Triangle ADB is a right angled triangle. So cos of angle ABD equals to DB by AB. Cos of 180 minus B equals to DB by AB. Minus cos B equals to DB by AB. Then DB equals to minus AB into cos B. The term DC equals to, we write AC into cos C. Consider it is equation 1. And here DB equals to minus AB into cos B, consider as equation 2. Now BC equals to DC minus DB. So from equation 1 and 2 we can write BC equals to AC into cos C plus AB into cos B. That is small a equals to B into cos C plus C into cos B. Next case, if triangle ABC is a right angled triangle, then cos C equals to BC by AC. From diagram we know BC equals to AC into cos C. And BC means small a, because BC is the side and it is denoted by small letters, that is small a, and AC is denoted by small b. So small a equals to B into cos C. Then if we added 0 to the right side, there is no change, so put 0. In place of 0 we can write C into cos 90, because cos 90 value is 0, so 0 into C is 0, so there is no change. Then cos 90 we can write B is the indicates 90 degrees, so in place of 90 degrees write B. Then we get small a equals to B cos C plus C cos B. So now we see one example or one problem. In any triangle ABC, show that S into A plus B into cos C equals to small a plus small b plus small c. So solution, sorry, that is not yes, that is summation of, that means sigma. It is wrongly printed. In place of yes we have to consider it is a sigma. So that is cyclic summation. We already discussed it in the previous class. Let us see once more what is sigma. Sigma of A plus B into cos C. So take LHS, and LHS is given is sigma of A plus B into cos C. And we are expanding, or we are extracting, or we are showing in the full form. That is, by removing sigma we are writing A plus B of cos C plus A plus B after comes B plus C into cos C after cos A. So B plus C into cos A is the second term. And next plus, and after b plus c we get c plus a, and cos a after cos b. So this three summation is indicated by sigma. Simply one term taken and sigma applied means the summation of cyclic summation, because in a triangle three sides three angles, so total three terms comes. If we write again the first term is repeated, so we have to stop, don't repeat, just we have to complete the cyclic. Next, so we are here, sigma is expanded, or short form is written in the full form. Next, that equals to, if we multiply with cos c in the brackets given terms, though we get a cos c plus b cos c, and similarly second term b cos a plus c cos a, and third term c cos b plus a cos b. Next, if we write a cos c plus c cos a put together, and b cos a plus a cos b, and c cos b plus b cos a, because the all are summation form, so we can change their orders, front or left or second term place is changed by third term, like this, because so there are additional properties here we are applied. So in the summation 2 plus 3 plus 5 is equals to 2 plus 5 plus 3, so there is no change. So for our required answer we are shuffling, so we can simplify a cos c plus c cos a means small b, we already know, or we already proved in above. We saw in above PPTs also. So from projection rule we can write, and similarly second term is replaced by small c, and last term is replaced by small a. So b plus c plus a is nothing but a plus b plus c. So hence we showed. And next question we will observe, in any triangle ABC, show that a minus b cos c by c minus b cos a equals to sin c by sin a. LHS, take the LHS. So LHS is a minus b into cos c by c minus b into cos a. Here, in place of a, from projection rule, I am writing b cos c plus c cos b, and minus b cos c as it is. And in the denominator, small c is replaced with projection rule. That is, in place of small c, I am writing a cos b plus b cos a minus b cos a. So positive negative terms get cancelled. Then remaining we have c cos b by a cos b. So cos b get cancelled. The remaining term is c by a. And from sine rule we know c equals to 2r sine c, and small a equals to 2r sine a. So 2r get cancelled. Then remaining term is sine c by sine a. Next question we see, in any triangle ABC, prove that sigma of cos a by c cos b plus b cos c equals to a square plus b square plus c square by 2abc. So solution, in the solution take LHS, that is sigma of cos A by C cos B plus B cos C. And we know in the denominator we will use the projection rule. So in place of C cos B plus B cos C, we can write small a. So LHS becomes sigma cos A by small a. And that equals to cos A formula from cosine rule. We can write B square plus C square minus A square by 2BC. So already in the denominator we have A, so it becomes 2 into ABC. And now we are extracting the sigma form. That means we are removing the sigma and we are writing in the complete form, that is cyclic, summation of cyclic. So first term write as it is, and after that plus, and B after we know C, and C after A, and A after B. So the second term is C square plus A square minus B square by, so 2ABC. Denominator is unchanged. Why? Because in the denominator the product is given and the product is in the form of complete cycle ABC. That means in place of A you write B, and B plus C, and C is replaced A. Again you will get same ABC. So there is unchanged. And third term in the numerator, C after A after B, and B after C. So A square plus B square minus C square by 2ABC. See here, term to term you have to put addition symbol, but in the term at beginning what is in the form, if it is plus you write plus in between, if it is minus you write minus. After completion of complete term, then you have to add, because sigma is summation of cyclic. That is we have to remember here. And LCM is same 2ABC, because 3 are containing same denominator. Then after LCM we get A square plus B square plus C square by 2ABC. It is RHS, hence we show. Let us see another question. Number 4. In a triangle ABC, show that sigma of A into B square plus C square into of cos A equals to 3ABC. In solution, take LHS, that is sigma of A into B square plus C square of cos A. Here expanding the sigma, we know how to expand. First term write as it is, A into B square plus C square of cos A, and put addition symbol plus, and A is after A we write B, so B after C, so B into C square plus A square cos B. And from second term we have to write the third term, so make the third term from second term. B after we know C, so that's why C into, and C after A, so A square plus A after B, so B square into cos B after cos C. So this is the, in a triangle ABC, so 3 terms comes, so write 3 terms and stop it. If you write again fourth term, again it is comes first step term as a repeated, so don't repeat, just stop it and multiply with within the products, because after simplification we get the required RHS. So multiply with A cos A with B square, so AB square cos A and AC square cos A, and like second term BC square cos B plus A square B cos B, and C into A square into cos C, and c into b square into cos c. And see here, first term and fourth term, if you observe, the underline are given, first term and fourth term. See here, underline terms, that both the terms we can observe the AB is common product. So take AB common from both the terms, then we get AB of B cos A plus A cos B. And like third and last term, we can take the common BC. So we write, after taking BC, C cos B plus B cos C. And remaining two terms, we have to take the common AC. Then AC of C cos A plus A cos C. So AB write as it is. B cos A plus A cos B is replaced with projection rule, that is small c. And in the second term small a, and in the third term small b. So ABC plus ABC plus ABC means 3ABC. And next question, that is fifth. In any triangle, show that a of cos b plus cos c equals to 2 of b plus c into sine square a by 2. So take RHS, 2 into b plus c sine square of a by 2. 2 of b plus c into 1 minus cos a by 2. So 2 get cancelled. Then b plus c into 1 minus cos a. So b plus c into 1, b plus c, and minus as it is, b plus c into cos a, b plus c cos a. And in place of b, from projection rule, we can write a cos c plus c cos a. And in place of c, a cos b plus b cos a. And in the last term, we have to multiply with cos a of each in the bracket bracket kept in the terms, what are, that is b plus c. So b into cos a, and minus is there, so minus b cos a, minus into c cos a, so minus c cos a. And again, if you observe the positive and negative terms, they may get cancelled. So cancel the terms. After the cancellation, we have two terms, that is a cos b plus a cos c. We took the a common from both, we have a of cos b plus cos c. So we got LHS. Sometimes we have to take RHS and find the LHS, because from LHS to RHS, if we see the steps, it is somewhat difficult to prove from LHS to RHS. So here RHS is, if we took, we get easily LHS. So sometimes we have to try from, generally we tried LHS to RHS, but some questions are not easily comes, so then we need not to worry. From RHS we have to show LHS. See, any side of the part if you take, and you have to show remaining side. And if you want LHS to RHS, you can write from reverse, LHS to RHS. So no problem, if you take LHS, you have to prove RHS, and if you take RHS, you have to show LHS. That means one side you have to take and one side you have to prove. If you want both sides, you can write the reverse order. So the fifth question, if you observe, RHS is easy to show the LHS. If we take RHS, we are easily got LHS. So that's why here RHS is taken. Next, tangent rule. In any triangle ABC, tan of A minus B by 2 equals to A minus B by A plus B into cot C by 2. And similarly, tan of B minus C by 2 equals to B minus C by B plus C into cot A by 2. And tan of C minus A by 2 equals to C minus A by C plus A into cot B by 2. Now A minus B by A plus B equals to, we already know from sine rule, 2r sine A. A means 2r sine A and B means 2r sine B. So substitute there, and 2r is taken common from numerator and denominator, so both r get cancelled. The remaining is sine A minus sine B by sine A plus sine B. See here, sine C minus sine D formula used. So that is 2 cos of A plus B by 2 into sine of A minus B by 2. That means transformations formulas we already know in the previous classes. And in the denominator, sine C plus sine D formula used. That is 2 sine A plus B by 2 into cos of A minus B by 2. Here in place of CD we have AB. So 2 get cancelled, and cos by sine means cot, so cot of A plus B by 2, and sine by cos means tan, so tan of A minus B by 2. And A plus B is replaced with 180 minus C by 2 as it is, and tan of A minus B by 2. So 180 by 2 means 90 minus 90, and by 2 also comes to C. So C by 2, 90 minus C by 2. 90 minus C by 2 means first quadrant, 90 minus means first quadrant. So all are positive, and 90 means cot changes as a tan. So tan C by 2 into tan of A minus B by 2, and tan of A minus B by 2 equals to, tan C by 2 comes to the left side, it is in the denominator position, and 1 by tan C by 2 means cot C by 2. So finally tan of A minus B by 2 equals to A minus B by A plus B into cot C by 2. So here tangent rule is proved. So here mainly tan and cot terms are shown by seeing, we can say. So it is in the form of tan and cot, so that it is called tangent rule. See, in the sine rule you can observe sine terms is there. In the cosine rule, so cos terms are there. So here tangent rule means tan terms are visible. So after proof we have to see the question. In a triangle ABC, if small a equals to 38, small b equals to 34, and c equals to, here c angle C equals to 62 degrees 40 minutes. So from the measurement we can say it is an angle C, because given in a degrees and radians or minutes. Okay, find A minus B. So here A minus B means angle, so difference between A and B, that is A minus B. So from tangent rule solution, from tangent rule we know tan of A minus B by 2 equals to A minus B by A plus B into cot C by 2. So small a is given 38 and small b is 34. So substitute, and cot C is given 62 degrees 40 minutes. So by 2. So 38 minus 34 is 4. 38 plus 34 is 72 into cot 62 degrees 40 minutes by 2 means 31 degrees 20 minutes. By using calculator we get 0.0912. So a minus b by 2 equals to 5 degrees 12 minutes. That means tan inverse of 0.0912 is, if we entered in the calculator, we get 5 degrees 12 minutes, and we need a minus b, so send the denominator 2 to the right side. It becomes multiply with 5 degrees 12 minutes, so a minus b equals to 10 degrees 24 minutes. This is how we got by using tangent rule. And we see another question. In a triangle ABC, if small b equals to root 3 and small c equals to 1 and capital A equals to 30 degrees, find B. Here angle B, because capital letters are indicates angles, we already know. So solution is, take here tangent rule, that is tan of b minus c by 2 equals to b minus c by b plus c into cot a by 2. Substitute b value and c value, side values, and in place of a, if you put 30 degrees, so 30 by 2 means cot 15 degrees, and that equals to 1, and 1 is written as a tan 45, so tan get cancelled, then b minus c by 2 equals to 45, and here the denominator 2 goes to the right side, it is multiply with 45, so b minus c equals to 90 degrees, given a equals to 30 degrees, so b plus c equals to 180 minus 30, b plus c equals to 150 degrees. Because a plus b plus c equals to 180 degrees, we already know. Solving 1 and 2, we get b equals to 120 degrees, because cc get cancelled, 2b equals to 240, then b equals to 120 degrees. So here solving means add the equation 1 and 2. Okay, so this is how we got the angle b. So see the summary. In this session or period, you learned that in any triangle ABC, small a equals to b cos c plus c cos b, and small b equals to c cos a plus a cos c, and small c equals to a cos b plus b cos a, which is known as projection rule. And tan of a minus b by 2 equals to a minus b by a plus b into cot c by 2, and tan of b minus d by 2 equals to b minus c by b plus c into cot a by 2, and tan of c minus a by 2 equals to c minus a by c plus a into cot b by 2, known as tangent rule. See here, if you observe the tangent rule, left side is tan of a minus b by 2, and right side cot c by 2, because here we have to remember we have to observe the formula. Left side is AB angles given and right side C angle given. That means AB is not came. And right side sides are taken, that is side A and side B. So by this variation we can remember tan of a minus b by 2 equals to a minus b by a plus b into cot c by 2. And similarly, tan b minus, that is not d, that is b minus c, the wrongly printed there, so correct it. Tan of b minus c by 2 equals to b minus c by b plus c into cot a by 2, and similarly tan of c minus a by 2 equals to c minus a by c plus a into cot b by 2. So this is known as tangent rule. So we learned projection rule and tangent rule. Let us see the quiz. First question, in triangle ABC, small b equals to, that means projection rule, if you know, you can find the answer easily. So answer is C, that is a cos c plus c cos a. And second question, in any triangle ABC, a cos b plus b cos a plus b cos c plus c cos b equals to, so answer is C, that is a plus c. And some questions asked frequently, so you have to prove them. And if you have any doubts, ask me and do the exercise problems. If you understand these problems, so similar problems from exercise you can do easily. And before going to do the problems, read the formulas and write each formula 10 times. Then you start the problem. And if you not get the solution from LHS, you take RHS and show the LHS. No problem. Most of the problems are you can solve from LHS to RHS. Some problems may not show because it is difficult to show. We have to then take LHS, take RHS, and from RHS we have to show LHS, because sometimes we have to if we take an LHS to show RHS, in some problems we have to need to add some terms or products and divides. So it is difficult to remember which should add and subtract or which should multiply and divide to the LHS for bring RHS. So that's why in few questions it is not coming from LHS to RHS, means we have to change the procedure. That means take RHS and use the formulas, simplify. Then in our mind we have to, if we take an RHS, in our mind LHS should be there, because the problems are here mostly they are asking prove that or show that. So according to the LHS or RHS, if you take LHS means you have to remember what is RHS, and according to RHS you have to use the relevant formulas. Suppose RHS is in terms of sign, so finally you have to convert the terms into the signs. So like that. If it is in cos, you have to convert the LHS terms into the cos by using relevant formulas. So when it is possible, if you remember the what we have to show. If you take an LHS means you have to remember RHS, or you have to observe the RHS, how the RHS is, in which terms it is there. So then you can easily prove or showed whatever it may be asked. So this should be remembered. And before watching my video, you have to open the PPT in another device, because sometimes screen clarity may miss in video. So I don't know why it is clarity is missing, because there is some technical related issues, so we cannot point out, or we cannot fix the issues. So but we can overcome if you see the PPT in another device, and if you listen the video of this related PPT, then the audio is clear, so you can overcome the problems of screen clarity. Okay. So do the problems, and if you have any doubts, ask me or mail me. Thank you.